Hello, everyone, and welcome to our very first Oracle ACE live session. My name is Wana Bonu, and I'm the community manager of the Oracle ACE program. And I'm truly excited to have you joining us today as we launch this new webinar series designed to bring you world-class expertise, fresh perspectives, and real-world Oracle insights directly to the global tech community. Before we get started, for those of you who might be new to the Oracle ACE program, we'd like to just take a short moment to introduce that to all of you. The Oracle ACE program is a global advocacy initiative created by Oracle almost 20 years ago, and it recognizes and supports tech experts who are passionate about sharing their Oracle knowledge and giving back to the community. Today, we have over 500 active members in over 55 countries all around the world, developers, architects, DBAs, IT leaders who regularly share their insights through a variety of ways, such as blog posts, webinars, presenting at conferences, doing podcasts, user groups events, forum activities, volunteering, and much, much more. So our Oracle Aces not only stay on top of the latest Oracle technologies, but they also inspire others to learn, connect, and innovate. And if you here are also an active community contributor and you'd like to join us in the future, we invite you to submit a nomination at ace.oracle.com/nominate. Or if you have any questions, feel free to reach out to us on any of the channels that you see here in the slide. We are delighted to launch ACE Live as a new way for you to engage with our top Oracle ACE speakers, a way to gain practical knowledge and stay up to date with Oracle's most important achievements. It is my pleasure to introduce our very first speaker, Jim, who's an Oracle ACE director. Jim is a recognized thought leader with decades of experience in data management, analytics, Oracle technology. Today, Jim will be taking us through his presentation, Reveal Hidden Assets and Strength with 23AI Knowledge Graph. So whether you're navigating organizational change or simply want to make the most of your enterprise data, today's session will be packed with valuable and actionable takeaways. So let's give a warm welcome to Jim, and thank you again for joining us for our first ACE Live session.
Thank you very much for that really nice introduction, Juana. I hope everyone can see my screen okay. Good. It says we can. Let's get started. My name's Jim Czuprynski. I'm Chief Storyteller at Zero Defect Computing Incorporated. These days, I'm basically a traveler and public speaker. I was actually at a conference a few months back, and my badge said influencer. So apparently, I'm an influencer as well. As you can see, I've co-authored a few books. These days, I spend a lot of time with the Analytic and Data Oracle User Community, or ANDOC, as we like to call ourselves. I'm their user community liaison. I'm also an optimistic futurist. Yes, that is me on stage dressed as Mr. Spock wearing ears. Best place to reach out to me is probably LinkedIn. After this presentation, if you want to reach out to me. I have a few followers out there. You can email me at jim@jimthewhyguy.com. Follow me on Blue Sky if you wish to as well. And my title that I kind of gave myself is Jim the Why Guy. I like to focus when we talk about these presentations about the why of what we're doing. And today I'm going to spend most of my time talking about knowledge graphs. Okay. So let's take a look at a true world business example that we can leverage. This is actually inspired by a fellow ACE pro of mine. Your parent company has decided to expand through merger and acquisition, M&A. And your CTOs come to you and said, Jim, dude, depending on his age, what do we have? We just absorbed two companies. I think they've got some EXA something stuff. And also, we're going to be doing an AI forward orientation. Have you heard that lately? Yeah, hearing a lot from my colleagues. What do the people that have just joined our IT organization actually know? And how many of them are ready for an AI forward organization thrust, if you will? How am I going to figure this out? Well, knowledge graphs might be one way to make this happen. So, what's a knowledge graph? Well, it's an interesting part of a way of dealing with data. First off, you may not know this, but graph database has been embedded in Oracle for a very long time. First time I actually knew a little bit about it was, I believe, Oracle 12c, somewhere right around there, around 18c, if I remember correctly, or 19c. I think it was either 18 or 19. We got property graph support. And in 23AI, we got operational property graphs or OPGs. In fact, that graph up here, you can see over here on the side, on the right-hand side, that's an actual visualization of a social media messaging graph that I built. It's simulated, but it actually has some real-world comments in it. And as you can kind of see here, what are we mapping in a property graph? Networks of entities. And so a lot of times you're going to see property graphs used to do things like figure out how things are connected. How are people or organizations connected? It gets used a lot for fraud detection. I give Awana money. Awana buys a painting, gifts it to Cassandra. Cassandra sells the painting to someone else and sends me the cash. That's a typical pattern that you might see in fraud detection, right? Where people are trying to launder money, for example. Not that my two colleagues would be available for that. Sorry, let me be plain on that. But again, we're connecting typically entities. Knowledge graphs are different. They're focused on networks of resources. And now I'm going to start throwing a whole bunch of acronyms at you. RDF, Resource Description Framework. That is a form of a knowledge graph, or I like to call them KGs. What does it link together? It links together URIs, Uniform Resource Identifiers. It's a standardized string. What's a URI? A standardized string. It is a simple way to identify a resource. What's a resource? It could be a physical object. It could be, say, a hard drive inside a storage cell with an Exadata database server. Could be, right? Database machine, I should say. Could be a reference to a document, a web page. It could be a reference to a concept. Oh. URIs look a lot like URLs. In fact, they're the superset of URLs, but a URL, while it isn't a URI, all URIs are not URLs. If you get anything from my session, there's something new you might not have known. Okay. So again, networks of resources. And more than a property graph or an operational property graph, they represent an ontology. What's an ontology, right? Well, it's something that's been built by an ontologist, not an oncologist. That's something bad, right? But an ontologist is someone who is essentially a knowledge scientist. They really, this is more of a data engineer than any other type of data engineering. By the way, it is not the concept of ontology that you learned in college during philosophy class. As the t-shirt says, I have a degree in philosophy. Why do you want fries with that? Philosophy is useful, but here we're talking about knowledge, really graphing knowledge together. You're going to see a whole bunch of terminology here. I love the one called OWL, which stands for Web Ontology Language. Why did they make it OWL? I don't know. You're going to see all kinds of new acronyms. Why they named them this way, I don't know. Okay, they just did. BGP, basic graph pattern, you're going to see that. Sparkle, that's another thing. SCAS, R2RML, go with it. This is like diving headfirst into machine learning. If you never knew what an algorithm was, or you didn't know what classification or regression was, it's as complex as that. But essentially, it is a great way of figuring out knowledge, organizing knowledge in a different way. Now, if we're used to relational data, right? We all know this. This is a typical way we might lay out data in a table, right? I've got 9 columns, 9 rows, uniquely identified by EMP ID in this case, right? We know that. That's a primary key relationship, a constraint that's placed on this. And then we've got other aspects, right, or other elements of information about, in this case, it looks like they're employees, right? Notice, by the way, they're on the far right-hand side, that MGR ID. Yeah, we can also have self-referential aspects of this, okay? So again, here we have actually three of the employees are identified as managers of other employees. So again, this is the way we usually look at things in a relational pattern. Not so much for knowledge graphs, right? If you think about RDMS environments, we typically show an ERD, an entity relationship diagram. Companies have assets and employees. Employees have skills, and the intersection of skills and when they achieve them is in the skills survey tape. And it's a very traditional way of looking at things. Knowledge graphs are more like class diagrams. Jim's going to talk about object-oriented programming. No, 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 no. But if you did OOP back in the day, you know what an object-oriented program methodology is, right? In this case, I've got a class diagram, and notice it's a little different than an ERD because a company offers a job. Company hires employee. Employee acquires skills. Companies require skills as well, right? Uh, Again, there's already an element here of implied knowledge and relationships. And why is this important? Because in an RDBMS environment, typically the business rules are buried in code somewhere. PL SQL triggers, primary key constraints, foreign key constraints, right? Sure, there's metadata, there's column and table comments, right? If you're lucky, the business logic's not inside the application. Most banking applications probably have it buried somewhere in a COBOL module. That's the way it is, right? Knowledge graphs can, and I'm going to keep this really simple because it can get very complex, can store and enforce the business rules internally without any additional programming. I don't need to create a PL SQL trigger that or some other relationship that makes sure that an employee only has one manager, for example, right? I can apply those inside the knowledge graph itself if I'm a good ontologist. So that's the basics of this. What does a knowledge graph look like on the inside? Well, if you notice up at the top here, we've got that HTTP colon, da, da, da. Well, that looks like an URL. Well, no, actually, it's a URI. It describes a class of employee. And what do I have here? What's this EDB colon thing? Well, if you think of that as a prefix or an abbreviation for that big URI up at the top, you've got it. And what are we describing here? Remember that table I had with the 9 rows and the 9 columns? This is what employee 108 would look like. And here's the cool thing about knowledge graphs. This is the easy part to grasp. Subject, predicate, object. If you get that, you've captured the majority of what we're going to be talking about today. Subject, predicate, object is the way we learned language. Jim has a dog. The dog is brown. Oana likes dogs. Oana might like Jim's dog, right? Subject, predicate, object. If you look here, employee 108 has an employee ID of 108. Employee 108 has a first name of Milton, a last name of Wadhams, and so forth. By the way, there were 9 rows here in this table that I showed you, 9 columns. There's actually 1 extra. By the way, these are called triples. Triples. Why are they called triples? Because there's 3 of them. Subject, predicate, object. There's actually 1 extra triple that says, hey, there's an instance, number 108, that describes this instance of the employee class. So that's basically what we have here, triples, not tuples, triples. If you get this, you've got a good part of understanding of how knowledge graphs actually work. Now, let's walk through a full-blown example of how you would deploy a knowledge graph. I'm going to start with relational tables. I'm going to build what's called an RDF graph view. From those relational tables, I'm going to stage their data from those RDF graph views into a staging table. I'm going to then create and bulk load an RDF graph. And then steps 6, 7, and 8, we're going to use what's called Sparkle to query the table, the RDF graph to see what's inside it. We're going to then take a look at SEM match, stands for semantic match, to actually use essentially a select statement inside the Oracle database to probe the RDF graphs. And then we should have enough time to talk about inference features. Okay. And that's what makes ontologies, knowledge graphs, stand out, in my opinion. So the first thing I'm going to do is create a new user, RDF user. Can name it anything. Could be, Honeychild. It doesn't really matter. But I'm going to grant it some basic standard grants, make sure, I've identified it with a password and so forth. A couple of key things I'm going to do here is also I'm going to grant it the graph developer privilege, and I'm going to give it Graph Connect through Graph Proxy User and give it ORDS privilege, right? Oracle REST Data Services privilege. So you'll see why I'm going to use something called the UI and the query and UI server for graphs. You'll see it in just a little minute here. But the ORDS enablement lets me use that. More on that coming up in about 6 or 7 minutes. Now I've got a user. I'm going to create an RDF network. What's an RDF network? A collection of RDF graphs. Simply all that it is. I've named the network MNA. It's owned by RDF user. So that's just basic infrastructure here. Let's move on to step 2. I'm going to drop and then create a new RDF graph. Why am I dropping it first? It might exist. I'm sorry. I'm a little anal retentive. I'm a DBA. I always guess the object might exist first. So what I'm going to describe here is a really long string. Remember that prefix statement that I showed you? Or I should say that thing with the colon. Remember that a couple slides back? Notice that I've described 2 specific prefixes, one called CMPY, another one called HWC. HWC for hardware components, company for company. And now I'm mapping a specific table that I've created earlier, right? That has information about companies. And I'm mapping the columns and the table to this class. See that like 5 lines down in the dark blue? Class, company, companies. Yeah, I'm basically mapping those elements, those relational database table elements into a knowledge graph class. I'm going to do the same thing with another table called hardware that has a bunch of hardware assets. Oh, one other thing, very important. Notice there I have HWCID, RR data type, XSD integer. What? Yeah, by default in a knowledge graph, all elements, if you will, are string, unless you say otherwise, right? So in this case, I'm saying HWC ID is integer. Parent ID is integer. Company ID, nothing stated. It is therefore string. There's also date data types and timestamp data types. I don't have any specific examples of those, I think, but yeah, you get the idea. And then finally, what I'm going to do, this is towards the end of this statement. This, by the way, is in a language called Turtle. I told you I was going to throw acronyms at you. This is probably the most complex thing you're going to see today, except for some Sparkle examples. What am I doing here in that red box? Well, remember I said I have the ability to do hierarchical mapping inside a table? I can do the same thing inside a knowledge graph. So in this case, I've got a parent ID for another hardware component. Think an Exadata database machine. It has storage cells. It has compute nodes. It has network components. Inside that storage cell, I've got possibly disk drives. More likely, I've got solid state devices, right? Component, subcomponent, sub-subcomponent, grandparent, parent, child. I can describe that join condition and reflect that inside a knowledge graph. Also, I can map the company's entity, if you will, the company's class based on company ID over to information inside my hardware class. Finally, I create the RDF view graph. Notice SEM APIs dot, yeah, SEM APIs is the package that almost all knowledge graphs rely upon in 23AI. And actually, knowledge graphs go quite a bit back, I think, to at least 18C or maybe even 12C. They've been around for a bit, right? But what I'm showing you here today is all 23AI format, right? Anyway, that's what I do to create that graph. What's going to come out of that graph are a bunch of, what do you think is going to be inside it? Subject, predicate, object, triples. Wonderful. So that RDF graph view, to be a little more specific, that's what I created. I'm now going to create a staging table and look at the elements of the staging table. Sub, pred, obj. Just like I told you, subject, predicate, object. Jim has a dog, right? That's what's inside the staging table. I then use SEM API's export RDF graph view or RDF view graph to export the RDF graph view, a little confusing, into that staging table. What I'm going to do is that's going to export all the triples that have been constructed as part of that RDF graph view and load them directly into a real RDF graph. Again, I'm going to drop and create the RDF graph specifically, not a view, but an RDF graph. And then this statement here, semapis.bulkload RDF graph takes what's in the staging table, the triples, and creates an actual RDF graph. Now, I'm not going to have time to explain all of this, but underneath the covers, if we looked in SQL Developer, you would see now a whole bunch of new objects underneath the RDF user account, which represent the RDF graph or RDF graph view. That's how it's implemented. Okay, we don't need to worry about those because we have a better way of referencing them, as I'm going to show you in just a second. So I've taken you through what in about 7 minutes, what it took me about a week to figure out from the documentation, examples, and some help from, frankly, some Oracle PMs that really know RDF graph inside now. And they should be on the call today. So in case we do have some specific questions, they might be able to help us beyond my limited knowledge. Because I'm going to be honest, I'm not an expert. I am just learning along the way all about knowledge graphs and their power. So to follow on, here we go. Let's go explore our knowledge graphs. How am I going to do that? The cool thing is you already have all the tools. We're going to look at using Sparkle. There's two ways we can go at this. SQL Developer, I'm going to show you that in a second, and also RDF Graph Server and Query UI. That one in the light green box there, if you go to the OCI Marketplace, again, I'm doing this all on Oracle Cloud, okay? You can specify a little task from Workplace to say, go build me the Oracle RDF Graph Server and Query UI. I'm just going to call it the Query UI because that's a mouthful. And build it. It builds a tiny little virtual compute instance, and I can access that. And I'll show you what that looks like in a bit. This link, I'm going to send our team the slides. That's a live link that'll take you directly to instructions on how to install it. But first, let's go over to SQL Developer, my old friend. Here I am. I've got my SQL Developer session up. And down here on the side, if you've always wondered what RDF semantic graph was for, this is what it's for, folks. And if I click on under their networks, you see that, oh, okay, there's an RDF user dot fam and an RDF user dot MNA. Remember, I declared this network was one of my first steps. RDF views are here. Oh, there's that R2 RML hardware assets RDF view, Jim, that you created. And here's the hardware assets graph itself. And one of the cool things I'll do, let me just share this with you. I can drill into this graph or this graph just by clicking on it. And notice up here, it changes sometimes you'll see model as another description for graph. That's why it's called regular models, right? But in this case, I've clicked on that hardware assets one, and what the heck is this? Welcome to Sparkle. Welcome to Sparkle. What are these things? Prefixes, remember, shortcuts to parts of the URI. Since I'm in SQL Developer and I'm clicked on the hardware assets RDF graph, it implies that whatever I'm going to access here is going to be related to the hardware assets knowledge graph. So I don't need to put a prefix in there for that. And I don't even really need these other ones. These are all the different RDF applications. Remember, we talked a little bit about OWL, WOL, right? There's an example of one of those prefixes embedded. Actually, if we took this all out, it would still work because they're all implicit inside Oracle's implementation of knowledge graphs. But if I run this statement right now, and I will, what am I going to get out? Basically the same thing that was here before. Where's the from clause? And here's where things get interesting. There isn't any. Well, there is, but we're not going to specify it here because it means something different. The from is implied in this where clause. Subject, predicate, object. This is what's called a basic graph pattern. What am I returning from it? Everything that's inside the graph. That's basically what I'm coming back with here. And notice, by the way, this one here has a string. It's defined as 2757 yada, 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 whatever it is. This is that one extra element that I told you defines, hey, there's an instance of the RDF graph class that refers to something identified with 275-77008, not whatever this thing is. And notice that over here, there's also a parent ID, subject, predicate, object, and note, this is defined as a decimal. Yeah, this is very specific again. If it's not defined as some particular data type, it's a string. Otherwise, you have to define integers or data types with this tag. And again, this is part of the precision of a knowledge graph, right? We assume string unless you tell me otherwise. And by the way, why is that important? I don't know if you heard about this, but one of the folks that was working in Doge to try to find contracts that were munchable, as from the United States Veterans Affairs Organization, used the wrong the wrong LLM that could not distinguish between strings and numbers, and therefore started munching contracts that he thought were worth 35 million. The LLM, because it doesn't know about numbers, read it incorrectly, and he was actually munching contracts that were worth only $35,000. And that's part of why I think it's so important that we have this decimalization or integerization, non-string specification for this. Notice that these two things here, though, the description and the type of the asset, are simply marked as strings. So that's what we've got here, right? This is the way I can access it inside SQL Developer. Sorry, brain went sideways there for a minute. So I showed you this. Whoop, let me come back to my slides. I've already showed you how to drill into this. And here's another example of how you could actually drill into some stuff here. I'm going to spend a little bit more time on this, but just be aware that in the where clause, I can also specify here's the elements that I would like to return. We're going to talk a little bit more about what happens when I have two different basic graph patterns here. What's happening here, right here, is I'm basically joining two classes together. A better example coming up in a minute. And then here's the data that's been returned. Okay, this is Sparkle. It's not hard to understand. I do have an excellent resource that if you do get flummoxed, that will help you understand Sparkle much more effectively with some marvelous examples written by the folks at MIT, so they know what they're talking about. And then again, I showed you that Sparkle query. Here's the stuff that actually would come out. And notice I've got in here the company abbreviations for Zeitgeist, Strickland, and Intercom. Those are my three companies, as well as other information inside here. Remember, subject, predicate, object. And the way I'm accessing this is a little different. There's a tab here. Let me show you actually in my SQL Developer environment. If I just click on triples, it will just dump out the entire contents of my specific graph in subject, predicate, object format. So that's the way that actually works, just in case you were curious on what that triples thing actually did. So that's one way to look at it. Let me show you another much more interesting and fun way to look at these data. Let me log into my RDF graph server query and UI environment. Let me just grab my password real quickly here. Why didn't I have it logged in already? Because in all my events, I've tried to have this thing. Oh boy. Okay, I gotta go back in there again. Let's try that again. I may have to just re-click in. Okay, let me go grab that real quickly again. Sometimes it needs a new session. Okay, here we go. And what I'm going to do here, oops, I should be able to just paste that in, I think. There we go. I'm now in the RDF graph server and query UI. That's a mouthful. We're just going to call it the query UI. I'm going to go in here and I set up a data source for my autonomous database, right? And notice, oh, okay, just like in SQL Developer, there's my RDF MNA, RDF user.mna RDF network. Oh, this looks just like SQL Developer. Okay, cool. Virtual models, I don't have any, but RDF views, yeah, this matches up perfectly to SQL Developer, or maps, I should say. Let's take a look at another graph that I've built called human capital. And what I'm going to do here is I can open it, but I just want to share this with you. Check this out. I can visualize this graph with a slightly different statement, a slightly different Sparkle statement called construct. I'm going to change that to 1000 because I know I have a bunch of elements here. And it's running this query and it's basically creating a graph on the fly. And I'm going to expand out all the elements that are possible. And this is another graph that I created because remember part 2 of CTO's order, find out who's got what skills and how many years of skills and how AI forward are they. I've got essentially the entire collection of about, I think it's 5 new classes that are all included. To uncomplicate this, I'm going to get rid of the jobs class and the skill job class. Okay. And I'm going to zoom in a bit here. This is really sweet. Take a look at this. Here's an employee, number 302. Here are the skills that she's acquired, everything from AI prompt engineer to AI MDL modeler. Well, how do you know that? Well, I built this class. But also, I'm going to just click on this information. I just right mouse button on it, and I can see this is, oh, it's Connie Sufanusafone. Okay, I know Connie. Yeah, she's an IT manager. She's only been with the company 3 years. She's already a manager. Wow, how cool is that? And she works for Strickland Energy Services. Okay, cool. I just did a right mouse button on that to see it. More importantly, notice that I've got a relationship implied here, not implied, definitely defined here, employed by Strickland. Yeah, remember when I created my classes and I said I could build in ontology information? This is exactly what I'm showing you here, right? And I think I can right mouse button on just about any of these and see what the information is underneath it. But this is a cool way of kind of getting a feeling for how everything is related inside your knowledge graph. And by the way, this is built with something called the Graph Visualization Toolkit. I didn't build it. A colleague of mine at Oracle, Rahul Tasker, who's on the spatial and graph team, did a fantastic job building this. You can also embed this, by the way, in Apex. It's not hard to embed this particular graph visualization toolkit in here, but they've materialized it here so that I can look at information inside here. So let me go back to my slides briefly here. Where are we? I've showed you how to do stuff in SQL Developer. I showed you that you can visualize a graph. That's coming up in just another slide here, which was right here. I can also, by the way, I'm just going to reverse my slides for a second. I can also run a query, just like I could in SQL Developer. I can write my own query. I'm going to show you some other examples of Sparkle queries coming up in just a little bit. And notice, this is pretty cool. Yeah, company name, Inacom. Yeah, that's the name of the company. But notice here, the employee ID, again, that's a decimal. We don't want to be guessing when it's coming to numbers. Is this a number or is this a decimal? By the way, if you're in the US and you have a zip code, that's a string. It's not a number because it can be shrunk to a smaller subset of zip codes, 606 versus 60638, for example. Okay, so a zip code's really a string when you get down to it. It's really not a number because there's an implied hierarchy inside that, believe it or not. Anyway, you can actually do exactly what I showed you in SQL Developer as well in the query UI. Okay, so I showed you the mapping already. Good. Let's talk more about basic graph patterns. And this is the hardest part of Sparkle. So let me help. Notice I've got a series of prefix statements up here. Remember, what's a prefix? Shortcut to URI, to a piece of URI. I've got a select statement in Sparkle. What are these things with the question marks? Variables. Where are the variables defined? To the right-hand side of these basic graph patterns. Notice it? Company name, skill ID, and so forth. But here's what I want to really emphasize to you folks. If you've got two or more classes in a knowledge graph and you want to link them together, this is the way you do it. I'm basically specifying a subject here with just an abbreviation, which is itself, by the way, a variable. But I have inside the employee schema or employee class and the company class two different names of different elements. For the employees, it's company ID. Company, it's company ID. They're identical in meaning and content. But if I want to link those two classes together, this statement here in the purple box is how I do it. This took me a week to figure out when I finally understood it. Oh, this is how I link them together because it's a basic graph pattern. Subject, predicate, object. That's the way you describe essentially a join of two classes inside a specific knowledge graph. Where's the from clause? This is it. There actually is a from construct in Sparkle, but it's not the same as the way we think of from in a select statement. But otherwise, this is not that hard to understand once you understand the syntax for joining, if you will, for linking together. What do I get out of this statement? Oh, okay. I've kind of shrunk some of the columns a little bit, but you can see, what did I get here? This is starting to look like a real query that I can make sense of. Oh, okay. William Lundberg has a monthly salary of that. It's a decimal. He has 7 years of skills as a project manager and also as a SQL developer. And Connie's not on our list. I don't see her here. Oh, she works for a different company. Peter Griffin's got 4 different skills, 2 years each. Some of them might be AI related, I'm guessing. They might be AI related. But again, this is what comes out of a typical query that we return either in the query UI Or in this case, I used SQL Developer. Okay. Understanding basic graph patterns is tough, but once you understand it, you'll never go back. It's once you understand select standard SQL, you never have to go back and reference it again. This is probably the second toughest thing aside from that R2 RML stuff I was showing you. So that's really cool, but I've got a third tool. It's called SEM Match. If you think of SEM Match as a wrapper that I can use instead of accessing the knowledge graph specifically or using the query UI, think of it like a wrapper for that. Take a look at what's here. Select. Well, that looks like a regular old select statement. You're catching on. And notice that I've glued together employee last name and first name as a full name, skill of briefing, skill years from table SEM match. This is a function that I'm actually calling. I'm going to feed into it a Sparkle query. Well, don't have a lot of choice about that. By the way, inside that Sparkle query, I could embed the prefix statements if I wanted to. There's another function of SEM match that lets me put them down here. This function is essentially the same as if I had, say, prefix EDB colon and put this up here as a prefix above the select statement. I'm using the human capital RDF graph as my target. So essentially, this is very much like just using either SQL Developer or the query UI, but I'm doing it inside a select statement. See how cool this is? And finally, this is what I get out. That's starting to look like good old normal SQL, isn't it? And SQL output. Exactly. So we've taken a pretty long walk here. What about inferencing? And I know you probably have some questions. Hopefully, I can answer them well, but give me another 7 minutes and we'll be all set. What if my boss has said we need to know who we need to retain or retrain or upskill or promote based on their AI forward skill sets? Where are you going to get that information? You better have some validation. So I went to go look. The US Bureau of Labor Statistics, BLS.gov, does have a standard occupational classification for people. But for some reason in 2018 and since maybe COVID, I'm not sure, they've never upgraded their standard occupational classifications to include, AI. The closest I could find was data scientist. So I decided I was going to have to build my own ontology. But here's the key point. What if I have an ontology that already exists in RDF format? Why would I take that data and suck it into my database, possibly breaking relationships or anything else that's built inside that ontology when I could simply reference it? That's the beauty of knowledge graphs, folks. I don't have to go ahead and convert the knowledge graph data into relational data. I can use Oracle relational tables, build a knowledge graph from it, and link to the ontology. For example, the Chicago crime database has, I think, 20,000 specific entries that go back to 2001 of violent crime in the city of Chicago. It's built into RDF format. If I wanted to build a database around that to look up crime data, why would I suck that data back into a database when I could just reference the RDF, which just basically comes out as a big file? Looks a lot like JSON or XML. So what I had to do was build a new ontology. I'll get to that in a second. Why would I want to do something like this? Well, let's consider answering this business question. I need a reliable, reasonably priced air conditioner delivered right away. Why? It's for my mother or my mother-in-law. She lives alone. Her air conditioner's broken. I need something reliable. You ain't going to get that from Amazon. Oh, you'll get the pricing information and the delivery date, but Consumer Reports has the reliability rating. If I have two ontologies from either of those with 4 triples, a third knowledge graph in that light blue box, I can embed that in a third graph and start building inferences. without having to reload or change any of the data. And as you can see here, what I'm doing is matching manufacturer to manufacturer, homepage to website, name to name as equivalent properties. And therefore, if I find a model number that matches between these two, or I'm sorry, a name that matches between these two, I precisely know exactly that these are the same thing. And I can get that reliability data linked to whether it's deliverable or not by tomorrow. So quickly, I created my own BLS skills ontology with a skill abbreviation. Notice not skill ID, but skill abbreviation, and an AI relevant score and some other data. I mapped it with R2RML real quickly. Basically the same process I provided before that I showed you. I then created a new RDF graph called skills integration. And skills integration has one triple in it. See that insert statement? Skill ID in the employee skill sets is the same thing as skill ABBR in the BLS ontology. These two graphs now have equivalence based on that. And now I can access them all together with one more step. This skills integration graph gets linked together with human capital and the BLS skills ontology to create a new RDF graph called inferred graph. And now when I run this query, what will I get out? It will effectively join those two ontologies that until now were separate, and I can calculate an average AI score rating. What's going on is in that BLS ontology, I've got a rating from 0 to 5, 0, no AI skill level at all for a particular skill, all the way to 5 for an extremely relevant skill. The BLS said that's what the skill level is. And if someone should have to leave the company because of that, I better have a reason to specify if I had to take that person out of our organization or move them into a different skill or job inside the organization that had nothing to do with AIT. And by doing it this way, I can now, with a simple, relatively simple SEM match Sparkle query, get out the following results. And I can see here that the average AI rating, if we decided to base it on that, Samir Nagahana, hard name to say, Nagahina Nanajar has the probably the best average overall AI rating. And I'm sorry, but Milton Wadhams, he of the red stapler, does not. Milton, by the way, his only two skills are COBOL and PL1, unfortunately, in my sample data. And that's okay, because Milton knows how to burn down the building if you know your office space trivia. Yes. Sorry, I was trying to make it a little fun, just a little fun. Okay. This is an awful lot of work. Why should I bother? First thing, let's talk about this. The ontology is the value. The business rules are buried inside the ontologies. Remember? That's the key factor here. If somebody's taken the time to employ an ontologist, which pays very well, by the way, and built this, why would you throw it away? Why not keep it there? Why scurry through application code or the business logic layer to find it? Also, standard ontology, right? Remember? String, number, only if I say so. Therefore, any system that links together as an RDF graph system will use the same axioms. If I say equivalent property, there's no fuzziness around that. They must be equivalent. Also, a standard terminology, right? If you've worked as a DBA, as I have for 25 plus years, and someone suddenly starts throwing SQL Server SQL at you, or Informix SQL, or DB2 SQL, oh, wait a minute, what? What's that? You don't have that problem here. Sparkle is Sparkle. The data vocabulary, the terminology is identical. And finally, the biggest challenge we have today for generative AI, RAG, and agentic AI. Trust me, I just did a keynote last week in Vancouver for BCOUG. It's a mess. AI is a mess. AI needs data, and it needs accurate data. This may be one of the best ways to solve the lack of precision in AI. Remember the example about the $35,000 VA contract that was supposed to be worth 35 million? Exactly. Just remember that. And there are many other examples of AI failures. Remember, one of the things that's neat about a URI is it can refer to a concept, a document, an image, a URL. And that would be an excellent way to more precisely identify the knowledge that we're feeding into it. Some things I learned along the way. We're almost done. Knowledge graphs are a very different way of identifying things. If you've done some object-oriented programming and you understand class and you understand all that good stuff, it will be helpful. But diving into this is almost as difficult as diving into headfirst machine learning. It took me a lot of extra reading to really understand stuff and experimentation. The graph UI and query tool set is really nice if you're visualizing. SQL Developer will work fine if you're developing Sparkle queries or going to use semantic match. Finally, Sparkle, super flexible, super powerful, difficult to understand, maddeningly confusing. Remember I told you about trying to figure out how to join? I looked through dozens of examples. Finally, I talked with one of the graph PMs and I was like, help me understand this. And he went, oh, you just need to flip these two things. This is why my hair's so short. I pull it out all the time. Once you understand it, you go, oh, okay, now I got it. But getting through Sparkle can be probably the biggest challenge when you're trying to get things to work. But be patient, be kind to yourself. You can get there. I was able to do it, and I'm not that smart, simply. Documents I got. By the way, that second to last one here, the Sparkle by Example one, that's the MIT one I was telling you about. They have a beautiful, just step through every single example and they show you exactly how to build Sparkle quite nicely. If you really want to get confused, go read the Sparkle query language for RDF knowledge from www.w3.org. It reads like an old COBOL manual. It's very difficult to understand unless you're steeped in understanding knowledge graphs in RDF already. And I have a few other references. One other one I wanted to mention was this one right here, GraphRag. Meliana Malai, one of my colleagues, and she's an PM at Oracle who works a lot with graph and spatial as well, did a fantastic session, a blog here that talks about GraphRag. And again, my viewpoint here is that's one of the primary reasons for knowledge graphs, to boost the ability to accurately send the right data up to a RAG application. And with that, folks, I got nothing else.
Thank you so much for joining us today, and a big thank you to our speaker, Jim, for sharing such valuable insights and practical guidance for all of us. We hope you found today's session both informative and inspiring, and that you're leaving here today with new ideas to take back to your teams and projects. In the next days, you'll also receive a follow-up email from me with today's recording. And this is just the beginning of our ACE Live series, right? We have a fantastic lineup of sessions coming up until the end of the year. We have one each month. We have Oracle ACE directors covering some of the most important topics and innovations in the Oracle ecosystem. I've already shared the link to the blog where you have information for all of that, but you can follow us on social media just to know when the next sessions are coming up. And of course, you can find them on the Ask Tom platform. You can register for them. And we invite you to recommend them to your colleagues as well, because our sessions are open and free for everyone. Don't forget to stay connected with us for more opportunities to learn, share, and grow together. And we look forward to seeing you at our next ACE Live session on October 22nd. So thank you again, everyone, and have a great day.
Have a great day, everyone.